Good evening, everybody. Welcome to the Richmond Society, our first event of the year. So Happy New Year, everybody. The Society still doesn't have a chair, and it will be apparent that I'm not Louise Fluker. Louise has ably covered the chair's role for better part of a year, more than a year. But whereas I got a pullover for Christmas, Louise got a knee. So she's on her back, as it were, and still recuperating. Apologises that she isn't here in person, but did say that she's going to watch online. And on behalf of everyone, Louise, we wish you the speedy recovery, and I literally hope you'll be back on your feet. In terms of safety announcements, nothing's planned. The exits are the green signs, and that's the way to go if there is an emergency of any description. The event is being videoed, and it will be posted in due course on the Society's YouTube channel. Members of the audience aren't in the view, but your voices will get recorded if you ask a question. So thank you for coming tonight and braving the cold, the sleet and the snow. It does seem a little ironic that we're here to discuss the effects of global warming when it is so cold outside. But Richmond Council's declared a climate emergency, and the government's policy is that the UK should reach net zero emissions of carbon dioxide by 2050. Now, there's a lot of discussion about this at the moment, and an increasing challenge about the costs of doing it. But what does it actually mean in practical terms for us? Most of Richmond's housing stock is old, and it was built at a time when energy was cheap and people weren't really concerned about the emissions. So we're not going to replace that housing stock, but to be more fuel efficient, we do need to retrofit. That means better insulation, installing renewable heating, and renewable energy technologies, the things like solar panels and batteries and so on. Now, if that's a minefield for the likes of me, we fortunately have got Michael Podesta to guide and enlighten us. Now, Michael is an eminent scientist who has practical experience of retrofitting his home in Teddington. He's going to tell us how these technologies can transform our homes, making them cheaper to run and reducing our own carbon footprints. Michael joined the National Physical Laboratory in Teddington in 2000, and he's worked mainly on problems related to temperature measurement. Apparently, the most accurate thermometer in history is based at MPL. I hope this is still the case. And it uses sound. So maybe we'll hear some more about that. Michael was awarded an MBE for services to science in 2009 and retired from MPL in 2020. Among other things, Michael produces a blog, which he's called Protons for Breakfast. Tonight, however, he's going to give us food for thought. So, over to you.
Thank you very much. Thank you very much for coming out here. It's very exciting for me to be here. This will probably be the most important talk that you will have heard so far this year. So it's about retrofitting Richmond, creating a future for Richmond's past. And so let's just gaze at the lovely things that we have in Richmond and think forward to the spring that will probably eventually arrive. Isn't it nice? So there are three parts to this talk. There we go. I want to talk about why carbon dioxide emissions matter. It's really important to get this into our head. It's not fashion, it's not wokeness, it's a really important issue. Then I want to talk about reducing carbon dioxide emissions from our homes. And finally, to talk specifically about the issues we have in Richmond as distinct from other places. So let's go. Let's take a look at why carbon dioxide emissions matter. So this is a graph. Along the bottom, it goes from the year 1700 up to 2040. So this is a lot of history in here, and on this vertical axis is billions of tons of carbon dioxide. 1 billion tons of carbon dioxide I don't think can be properly conceived of by the human brain. It's just impossible to think about. But the emissions currently are about 37 billion tons a year. That's what humanity puts in the atmosphere. And that's more than 4 tons for every person on the planet. So I expect that none of you have any consciousness that 4 tons of anything goes out anywhere in your life. It's more than all the garbage you put out in a year. So we don't have a personal sense of this, but it is having a massive effect. The effect is happening on the temperature of the planet. This is the global temperature anomaly. This is the difference in temperature from the range 1850 to 1900. So the average there is the baseline. And each blue dot on there is an estimate looking at thousands of meteorological measurements to get an estimate for the average temperature of the Earth's surface. That's the surface air temperature, about 2 meters above the surface. The gray bars are an estimate of the uncertainty in the estimate. And the red line shows the running trend. And you can see that this is an issue of our time. You know, things have been happening from the post-war era, particularly the 70s onwards. We've had this rising trend in measurements. And so if we look at, this is not last year, that's 2023 on there, focusing on that. That was by some big jump the hottest year that human beings in any kind of civilization have experienced. So if you go back to the dawn of civilization, in the Middle East, Babylonians, I can't remember the names of the civilizations, Egyptians, so on. By some measure, that was the hottest year human civilization has ever experienced. This year, the analysis has been ongoing and will be released on Friday coming, but it will likely be somewhere there. It will be hotter. Last year was hotter still. And so we're in this situation where these last 10 years, if you look at them there, are the hottest years human beings have experienced. And the awful, awful thing is that in your lives, going onwards, they will probably be the coldest 10 years for the rest of your lives. Because that trend is only going in one direction, and it's terrifying. Now, the trend is extrapolated. It's just a line drawn through a set of dots. The dots are real data. That is what has happened in the world. But the line is just a line. And it goes that way because we're doing something, and that's the way the Earth is responding. But we can do something different, and that line can go in a different direction. So we can, in particular, we can do things that make that line turn over. And to do that, we need to stop emitting carbon dioxide. And that's called net zero. We have no way to make the Earth cool. So the longer we take getting busy with this, the warmer the Earth gets. What's going to happen in future? Well, it's the future, so actually nobody knows. But this graph from Climate Action Tracker has got some different estimates. And basically now, the best we can hope for in the year 2100 would be that the Earth will have warmed by about 2 degrees and that the temperature will have stabilized at around that level. Like I say, there's no way we can make the Earth's temperature go down. That's the best we can hope for. What is probably more likely is that we will be up here. Where we're headed for now appears to be something like 3 degrees and still rising. Just to put these numbers in context, each tenth of a degree in global temperature is not like a tenth of a degree that you experience with your fingers. Every day the temperature goes up and down by 10 degrees or something like that, and a difference of a tenth of a degree between 2 days, human beings can't notice. But the trend here, but statistically we can pick out the trend in data, and it's happening too slowly for human beings to appreciate immediately as a temperature sensation. What we notice are the anomalously warm days, the early spring, the mild autumn, and so on. So that's how we notice it. So this is a summary of where we are so far. The climate in which we all grew up is gone. It's absolutely gone. And it's never coming back. Nothing we can do can ever reclaim that climate. Even if we emit zero CO2, the Earth won't cool. And the longer we wait before acting, the hotter the Earth will get. But if we try very hard, we can still avoid the worst outcomes. And all we have to do is to stop emitting CO2. So that's the situation in which we find ourselves. It's not a very good situation, but that's what it is. Would anyone like to ask any questions at this point? Before we can go on to. Before we go on to the next section, would anyone like to ask any questions? Oh, lady at the back there. Yeah.
Can I ask about other gases like methane gas? And we hear about other factors.
Yeah. So there are other so-called greenhouse gases. They don't warm the Earth as much as carbon dioxide, and methane, in particular, when it goes into the atmosphere, it warms the Earth intensely for about 7 or 8 years or something like that, and then it gets broken down into carbon dioxide. So we can do things to reduce methane emissions, and they will have an effect within a decade. Carbon dioxide doesn't have anything equivalent that we can do about it, and carbon dioxide has been built into everything we do. Occasionally one returns to Greek myths and thinks, God, they really did nail something about humanity. And one of the myths is the myth of Prometheus, that he stole fire, and that burning stuff is humanity's secret. It's our best trick. And that is so true, because all our technologies have been built on burning stuff. And the end of burning stuff is carbon dioxide going into the atmosphere. And so the situation we're in now is because that basic burning stuff to drive our technology is still at the heart of how we're living. Now, methane we can address, but the CO2 thing is sort of somehow more central to our civilization. Lady, gentleman there, yeah.
Peter Willan, could you, Michael, perhaps just give us a little bit of context of the UK carbon? I mean, I think the 50 billion tonnes or whatever it was the world, wasn't it? Or the 4 tonnes per person. We've got in the UK how much is it? And also the legal framework, the carbon budget. I think it might just help sort of without too much detail.
So I don't know much about the carbon budget for the UK things. It's all subject to political stuff, and I'm just not interested. In terms of the UK's, as it were, responsibility, its contribution to the emissions, the UK, if you judge historically, we've been emitting gases for a very long time. We're something like 6th in the planet. Obviously, the major emitter is China, US. I can't remember what the next order is. And I think the point you're trying to make is that we don't emit very much carbon dioxide compared to China, so we don't really need to do anything. China should do something and not us. Well, I think that's just, well, first of all, I think it's just morally, it's just an immoral view, frankly. We all have responsibility, and if you view sort of the smaller emitting nations together, each one of them, so if you take the smaller emissions nations, they'll amount to something like a quarter of emissions, and there'll be the UK, France, Denmark, and whatever. Each one is just a small amount. But if you consider them as a group, they're a quarter of the emissions, and everybody in that group has to reduce emissions. And so if you are saying that nations should, the poorer nations on Earth should suffer the consequences of global warming because of our emissions, but we're not going to reduce them even though we're much wealthier than them, well, you may feel comfortable with that, but I don't feel comfortable with that. Yeah, I'm just sort of addressing what I thought was behind your question. The lady here.
I've always doubted, obviously, that carbon dioxide is causing warming of the climate.
You've always doubted it?
Yes, because our planet, over the million years it's been created, it had heat periods, ice periods, heat periods, and obviously the carbon dioxide contributes to that. But what is your proof, and the question is, what is the other reason for the warming of our globe? Because I don't believe it's only the carbon dioxide.
Okay, well, you're simply wrong. It's part of a general stuff you see in social media. People say it can't be carbon dioxide. One, it's a very small concentration in the atmosphere. The Earth has been hotter and colder in the past and so on. And these things are true, but it is carbon dioxide. So the story is very, very interesting. So the first person who discovered the effect of carbon dioxide on infrared light was John Tyndall in the 1850s we're talking about now. And he understood that the Earth's temperature was established by a balance of, we have sunlight warms us up, but if we just got energy coming in, we just get hotter and hotter and hotter. So we have to have a balance of sending energy out into space. And then when there's a balance between energy in and energy out, where the temperature stays stable. And he was doing experiments on the transmission of what was not yet called infrared light. They were called obscure rays. So this sense that you have, I don't know if you know, if you have a garden wall and it's had sunlight on it, and you walk past it late in the evening and you feel the radiation. They didn't know what that was, but they could see that it could cast a shadow, you could block it and so on. And he was measuring the transmission through different things. And in the 1850s, he got around to measuring the transmission through air. And he was astounded, gobsmacked, you can see it in his descriptions, that air, which is completely transparent, absorbed this infrared light over just a couple of meters. He couldn't believe it. And so he did further experiments, and it turned out that it was not the air itself, it was not the nitrogen and the oxygen, it was just the water vapor and the carbon dioxide. So his astonishment was tripled, because it wasn't the bulk of what he was testing, it was these tiny components, the carbon dioxide and the water vapor, that were absorbing the infrared radiation. And he realized immediately the consequences for the temperature of the Earth, but he couldn't do the maths to explain the temperature of the Earth. We had to wait till 1896. 1896, 130 years ago, for the explanation from the scientist Arrhenius, who now, he wasn't worried about global warming or any of that stuff. The big question back at the time was what had caused ice ages. People were just learning about ice ages. There was a big intellectual thing to go out to the Alps and do glaciology and so on. And he wondered if it could have been a change in carbon dioxide concentration that had driven ice ages in the past. And he made a calculation of the effect of doubling carbon dioxide. And he said, if you double carbon dioxide in the atmosphere, it will warm the Earth. It will warm the higher latitudes near the poles. It will warm them more than the equator. And on average, he said, if doubling carbon dioxide would produce 5.5 degrees of global warming. At the last IPCC report, the estimate was that doubling concentration would warm between 3 and 5 degrees. So it was 130 years ago. It's a little bit high in his estimate, but completely nailed the phenomenon. We have understood this phenomenon for more than 100 years. What is happening is absolutely in line with predictions.
But the question is whether it is only the carbon dioxide
Yes,
which
it is.
causes the warming. And
Yes,
there
it is.
nothing else
People have looked. Can I tell you, if there was something else, people would be doing about it.
which is the position of the globe with regards the sun, the axis in which is position or distance or anything scientifically. Have you proven that it is only the carbon dioxide
Yes.
that causes the warming? That's
Yes, yes, that is the answer. It's not the answer you want because you're a climate change denialist. Can I say, there are people everywhere. You just don't want to know the truth. And there's nothing I can do. I can present the truth to you. If you don't want to believe it, your vote is worth as much as mine.
There is something else within the position of the Earth.
You're wrong.
Which also causes the changes of the climate, as has been done for billions of years.
In the past, those things have all affected the climate of Earth. But in the last 100 years, they are not relevant. This is caused by us. Okay, I think, is there a couple, perhaps we do one more and then...
We want the second one. We've come here for the second one. Right?
You come here for the second one. I promise you, the talk is not a very long talk. I think there's a misunderstanding. It's a half-hour talk, so
I shouldn't panic.
don't panic, I promise you. And I'll try and put in some jokes as well.
As to why carbon dioxide actually can absorb more heat than, say, oxygen, maybe a 2-line sentence to for the lady.
Why? It's the number of CO2. They describe the shape of the molecule. It's carbon and 2 oxygens. It's got 3 atoms. Oxygen and nitrogen have got 2. And when when the electric field in a light wave shakes the molecule, some of the energy is absorbed and re-radiated. Now, it turns out that when you've got 2, they're exactly symmetrical and they don't absorb or re-radiate anything. Methane, 5, even stronger. Other things, even stronger. Is it okay if I go on with part 2? You can ask me at the end. Okay.
Is carbon dioxide absorbed by anything, for example, plants?
Yes, it is absorbed by
So
plants.
is it recycled and,
Yes, there's a very interesting carbon cycle. So carbon dioxide is absorbed by plants, but then released by plants when they decay. Okay, so that was very interesting. So reducing carbon dioxide emissions from our homes. So how do we stop emitting carbon dioxide? I can't address all the ways that we emit carbon dioxide and things we can do, but from our homes, it amounts to more than 30% of UK emissions, so it's incredibly important, and it's to do with how we use energy. So let's take a visit to the kilowatt hour, which is the unit that you get billed for energy on your gas and electricity bill. When you consume gas, it leads to the emission of about 0.23 kilograms, a quarter of a kilogram of carbon dioxide. Most of that comes out of the flue of your boiler. Some of it was energy used to deliver the gas to you there. Now, emissions from electricity vary depending on how it's made. So let's take a look at how that has varied over time. So this is 1998 over here, and this is heading on to 2030. And this shows how many kilograms of carbon dioxide were emitted for each unit of electricity. And historically, it was about 0.45 kilograms, and now it's about 0.2 kilograms. It's a little bit less than 0.2 kilograms at the moment. And so this is because we're making electricity now with wind and solar, and the more wind and solar we have, the cleaner the electricity is. So let's take a look at a typical home. So these are some version of a typical home. Electrically, typically we use about 2,900 kilowatts, leads to about 0.6 tons of emissions. They don't take place in our home, they take place at the power stations and so on. Gas is typically 12,000 kilowatt hours, leads to 2.7 tons of emissions. Can I just ask you to focus on that 2.7 tons? You turn the gas on, the idea that 2.7 tons of anything goes out the flue is mind-boggling, which is sort of part of why it's so hard for people to acknowledge what is really going on. And together, that makes about 3.3 tons per year. Now, what I want to do is tell you about the carbon dioxide emissions from my home over the last few years. Now, I've estimated them by using this very high technology. Every Saturday, I go and read the meters. That's it. And I put them on a spreadsheet, and then I plot how much I've used. So here is days since the start of 2019, and this is the total amount of gas I've used. So that's in kilowatt hours. So to work out how many kilograms of carbon dioxide I've emitted, I multiply that by 0.23, and so we get a graph that looks very similar, except that now these are kilograms. And so we can see that back when I got started on this game, in the winter of 2018-2019, the house emitted about 3.5 tons of carbon dioxide. The next winter, it was about 3 tons. The next winter, it was about 1.7 tons. And then finally, it was 0 tons. So what's the magic that made that happen? So back here, we installed triple glazing. Why did we do triple glazing first? It was the only thing my wife and I could agree on. She was happy to have the glazing installed. And that made about 10% difference. In our house, we had very old glazing, 10 to 15%. Then we had external wall insulation put in. That was very stressful. But you can see it's reduced the heating load by about half, and the amount of carbon dioxide by about half. And then we had a heat pump installed, so we were no longer heating with gas, we were heating with electricity. And then we had the gas hob replaced with an induction hob. And then in March 2023, we got rid of the gas boiler. So that's the carbon dioxide emissions associated with each of those steps. From electricity, it's the same sort of thing, except the graph looks rather different now. This is kilowatt hours again, so this is straight off the meter. But now to convert that to carbon dioxide, I have to multiply it by a different number for each year because the electricity is getting slightly cleaner each year. But the graph still looks very similar. And so that's kilograms of carbon dioxide now. And so back in here, we're 0.75 tons in the year 2019. The next year, it's 0.6 tons, 0.75, 0.7, 0.75 tons. So you see the very strange pattern here. What did I do to make that happen? Well, in November 2020, we put on 12 solar panels just to catch the peak darkness. And they didn't seem to make much difference until we put in a battery. When with solar panels and a battery, we were able to trip off-grid for 4 months using no electricity from the mains. I can't tell you what an amazing floating feeling that is. You just think, wow, maybe it is possible to live a different type of life. Then we had the heat pump installed, so now we need to use a lot of electricity in the winter to heat the house. And then we have the summer again, and we have more solar panels. And then at this point, we bought an EV, a second-hand EV with very low mileage, just to take us around the beautiful borough. And if you look at the trend, you can see we're still less than we would have been doing normally, and we've got no gas. So when you put all these things together, over the years, we've gone down from 4.2 tons to 0.75 tons. It's an 80% reduction in carbon dioxide. And as the grid greens, because we're using electricity, it will fall further. And we will have, well, we do have an improved quality of life. The home is warmer and than it was. Looking ahead, so I don't know if other people do it, but I have a target date of death. I'm planning on dying in 2040. This shows, going up to my target, what the emissions would have been if we'd done nothing. And the green line shows what this plan is. And so you can see that when we did these changes, I've added in extra carbon dioxide emissions associated with the manufacture of a heat pump, triple glazing, external wall insulation, and so on. And they were very significant. They came to about 11 tons. But you can see that the emissions from the gas boiler particularly were so large that we're already now here, we're already in the payback region. One side effect of all this is that although I've spent a lot of money on this, the bills are ridiculously cheap. This is the actual expenditure this year on our electricity, which comes to about £161. So these things, how to reduce CO2 emissions, it's reducing heat losses, it's generating renewable electricity with solar panels and a battery, and stopping burning gas. Together, these things are known as retrofit. I hate the word, but that's what retrofit refers to, in some combination suitable for each home. And these are the steps that every single home in this borough not just needs to undertake, but will undertake in the coming years. At some point, you won't have a choice about it. So this is my home, and I just thought I would just go through a few pictures of my home and homes in the borough. You can see this is the beautiful, my back garden. You can see the heat pump there. That's triple glazing, that's external wall insulation. Here's the front of... I'm sorry, I missed that?
You said there's the heat pump.
Oh, you couldn't see it? I thought you would have noticed it because heat pumps are so offensive and people object to them so much. There's the heat pump. Sorry. Yeah. Here's the front of the house. There's solar panels on the front. Pretend bricks to match neighboring houses.
When was your home built?
1927.
So it's cavity wall?
No, solid wall. But basically the war was the divider. If it's pre-war, it's solid brick. Post-war is cavity. In general. You know how to spot it on the brick patterns? Yeah. Okay, so how I went out today and just took pictures of this house. I don't know which one of these houses it is just about to have a heat pump installed. These are houses that particularly people would generally say, no, you can't have a heat pump. It doesn't have any external wall insulation on. Any house that can be heated with a gas boiler can be heated with a heat pump. This house, you see it's got its big area of walls here. This house is extremely, the bottom 2 stories are one. That's all heated with a heat pump, very, 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 very sweetly installed. The people are really happy. Now, these are some other houses. I don't know whether these have heat pumps. So these are terraced houses. There's a lot of these in the borough. People often say, well, where can I install a heat pump? As if that. But I just took a picture of these just because people put their rubbish bins in front of their house. And somehow the idea that people would object more to a heat pump in front of a house than rubbish bins, I find remarkable. Anyway, they have very low heating requirements. There's a lot of them. These are the sort of modern equivalent. Obviously, there's still a lot of flats in the borough. A lot of this type of Edwardian dwellings. And so those are the sort of steps that people need to take. These are the houses they need to be installed in. And I just want to talk now about Richmond-specific things. Us. So this is our situation. We're in a climate crisis caused by carbon dioxide emissions. In the most optimistic scenario, the Earth will warm by about 2 degrees Celsius by the end of the century and be stable. In some scenarios, the warming exceeds 3 degrees Celsius and is keeping going at the end of the century. Now, the thing is, we have solutions to stop this. It allow people to live sustainably with massively reduced carbon dioxide emissions. There are heat pumps, solar PV, and batteries. I should have added insulation on there, but sorry? I should have added insulation on there. So what are our responses to this going to be? And I'm talking about our collective responses. So the response that I experience, as Stephen said, I retired in 2020, and I've undertaken this work. And slowly I've got involved helping neighbors and other people around the country who've got involved in this stuff. And this is the business as usual, is that there is absolute resistance to people trying to do anything. So people have raised the question of listed buildings, planning permission, and so on. So Richmond Council, for example, are absolutely appalling. I mean, I went to I was invited to talk to one of their committees, and there was a number of residents, an architect, telling them about the problems they had had. And then the person from the planning committee was asked to respond, and he said, well, there aren't any problems, which is, of course, the problem. And so the atmosphere has been created, particularly in Richmond, where owners of homes don't even think about renewable energy installations. They just think, oh, somebody told me you can't even put double glazing in. It just feels like so much effort to do anything that nothing gets done. That is the situation we're in now. Or we could have an attitude of sustainable action and recognize that every single dwelling in the borough will have renewable energy installations in the coming decades. It's going to happen. The gas network, the plans are being made to decommission the gas network, because at some point we won't need gas, and then when there aren't enough people who are using gas, the companies will say, well, we can't make money, so we'll wind ourselves up, and then someone will have to wind down the gas network. This is going to happen in coming decades. We're going to have to heat ourselves differently. And so in this response, we would create an atmosphere where installations take place as rapidly as possible, because we want to reduce emissions as rapidly as possible to minimize global warming, and to the best possible standard. So we have examples of good installations that have done clever things, and so on. Now, this is where, so I'm talking to you as members of the Richmond Society. Your purpose is to help keep Richmond a great place in which to live, work, and visit. And you do this, so these are off your web pages, so this is, this is you. Our purpose is we campaign to preserve Richmond's historic character, unique features, and amenities. And we're promoting high standards in planning, building, and landscaping. But the situation we're actually in is that if we reach 3 degrees of warming, then I don't like to catastrophize and predict what's going to happen, but there will be bad things. Going beyond 3 degrees, it's very likely that the ice sheets in Greenland and Antarctica will not be stable, and they will begin to melt. Well, they're already beginning to melt, but it's possible that we might be able to stabilize them. If they melt, then over the subsequent few hundred years, the sea level will rise. If Greenland's ice sheet melts, that's about 7 meters of global sea level rise. If the Antarctic ice sheet melts, that's about 21 meters of global sea level rise. And I speak to you as someone who is currently 11 meters above global sea level. You were only 10 meters. You know, you can come up here. You can come up here if it gets bad this evening. So the idea that we're preserving Richmond for the future by somehow not taking sustainable action just doesn't make any sense. You in the Richmond Society should be campaigning harder than anyone that every building in this borough, every single building, should be heated sustainably. No one should be forced to emit carbon dioxide to keep themselves warm. It's disgusting. You should be working with architects, with planners, to find smart solutions for your difficult buildings, instead of every individual having to pioneer themselves and work it out for themselves. So I think you should add to these things. You should be working to avoid catastrophic flooding in the 22nd century. If you really want to preserve Richmond, that is what you need to do. You should be promoting rapid installations now, this year, not next year, of renewable energy infrastructure in the borough as rapidly as possible. So the summary of my talk is this. Richmond upon Thames has a long history, and if we want that history to continue, then we need to install renewable energy infrastructure, heat pumps, solar PV, and batteries in every single dwelling in this borough as rapidly as possible. And I'm calling upon you, members of the Richmond Society, to play your role. People know that you're going to speak up for Richmond and that you want it to be beautiful. Well, speak up and make it sustainable and beautiful, and be an example that people can look to for how they can live sustainably with the benefits of our lovely environment, but with a sustainable life. Can I say thank you very much for your attention?
Thank you very much, Michael. Your passion is definitely not in doubt, and our orders are heard. What I would say is that the Society only in November, October, gave an award to Richmond charities for their work installing solar panels on listed buildings, and that was our recognition of what they were able to do by basically, clever architectural design in terms of being able to conceal these the solar panels behind the parapets. So,
can I say, so concealing solar panels behind parapets is one thing. Why not stick them on where everybody can see them? You know, we have things on buildings that are called chimneys. Have you ever looked at a chimney? It's the ugliest bloody thing in the world.
And interestingly, chimneys, of course, are part of the street scene that is preserved.
Yeah, exactly. So the question is, what do you want? Make up, I'd say it to all of you, make up your mind what you want. Do you want a place that looks quaint and is just part of a decaying, the end game of this society? Or do you want to try to build a place that's sustainable? And it's going to look different. It will look different, but it can be the way, what I'm saying is you choose what you want, but make it for the future and not the past. Sorry, I interrupted you.
No, that's not a problem. Are there any questions before we wrap up? So, unfortunately, I can't see particularly well. Let's go over there then, please.
Thank you very much, and we are challenged, and we will take what you say away, and I know the committee will.
Can I say thank you? That was my wish when I came here. That was my wish.
Yeah. Having said that, Tina and I are working very hard at the moment on our house, and we have to change our boiler, which is a gas boiler. And you will understand that for people who are not so knowledgeable as you, it's a very difficult process. It's so complicated. And simple things like we have an EV van, which has got a very large battery, but there's no way to connect that battery to the system in our house that we know about. So there's a lot of very practical challenges. You've given us a strategic view. Can you give us or repeat 2 or 3 of the tips that are some of the things we can do relatively easily? And
Okay.
You talked about the planning department. We've been told that we have to get planning permission for the I can never get it right, or the heat source, pump.
Yeah.
What's the
Air source
name?
heat pump.
Thank you very much. To get planning permission for it, so how do we take some initial steps that are, we're prepared to spend money. Most people in Richmond have got some money that they can spend.
Exactly.
But we're talking about anything between £10,000 and £20,000 as far as I can see. So we need to do that in stages. So any thoughts on tips that would help us with that journey?
So I spend a lot of my time responding to people who somehow found their way to me, asking exactly like you, I want to put in a heat pump, but I just don't know what to do, or I don't know who to speak to. So the first thing I say is, can you remember this phrase, protons for breakfast?
Pretty easy.
Okay, well, use it and look me up, drop me a line, and I will give you very specific advice. So the first thing is, I would say, don't be in a hurry. It's a mistake to be in a hurry. I would say do what I did, record your meter readings as you go and become aware of the energy you use. Now, today is a really great day, and I invite you to do this. It's a little bit difficult if you have old-fashioned meters, but if you have a smart meter, each day in this cold weather, when it's about 0 outside, record how much gas you're using. Do you have a meter that could do that?
We're currently doing a 3-week test.
Oh, fantastic. So if you record how much energy you use each day, so if you use, for example, 100 kilowatt hours of gas in a day, If you divide by 24, that tells you you're using just over 4 kilowatts to heat your home. So make sure the home is comfortable the way you want it, and that will help you work out what size heat pump you're going to need, and make sure that's got right. But becoming conscious of that is, I think, the first stage I would use. And if you're uncomfortable about it, I would say don't go ahead with anything. Wait until you feel comfortable. Don't be hassled by anybody to doing anything. People in Richmond often do have, as you say, 10 or 20,000 pounds they can spend on something. In Richmond, houses cost, some fraction of £1 million, and the idea of every 20 years spending 10, 20,000 on them is not an excessive idea. But I'd say just don't be in a hurry. Drop me a line.
Jadine.
Hi. Can I be cheeky and make a comment and ask a
yes,
question?
of course, yeah.
My comment is that I think the council is a big part of the problem. They are starting to have a debate, but it would be great if your councillors heard from you and the councillors heard from the Richmond Society, because I think that would really help. And my question was, you talk about external wall insulation, but it is possible to have it done on the inside. And my neighbour Judith, who I think you met at the council, has had that done. Is that as effective, and would you recommend that?
So your comment about the council. So the council are terrible. Can I say, it's filled with good people who are doing the best they can, just like everywhere. But collectively, somehow, it just can't get anything done. External wall insulation, internal wall insulation. External wall insulation is great if you've got a boring house like mine. You put it on, and all the brickwork warms up so that all the brickwork is sort of at the temperature of the inside. And so this means that as it's hotter, it's drier than it was previously. So you won't have any problems with damp. Internal wall insulation is a little bit trickier because there all the brickwork becomes a little bit colder than it was previously. And so you need, did you follow me? Yeah. So you're insulating the inside from the outside, and whether it makes sense or not depends. I know a lot of people had it installed and found it really, really effective. So they both work. You just need to be a little bit more careful with internal wall insulation. A lot of people will put it in a very specific place. So often, if you have bay windows, they're often built with just a single skin of bricks, and they're particularly cold. And so putting insulation there is a very, very sensible thing.
Yes, I've recently, from a house which perhaps I would have been able to do some of the things you're telling us, but I now live in a block of flats. What do you do? Are there retrofitting in flats, and how do you set about persuading the management committees and others to do it?
So it's a great question, and I don't know the answer. I'm very sorry about that. Everywhere else in the world, people just stick an air conditioner, which is a type of heat pump, on their window, and that's it. Now, here, people are obsessed with the way things look, and that's it's not generally allowable. But you can put the heat pump on the roof. So if you're in a flat, so a lot of talk, so many things. A lot of talk is about what are called air-to-water heat pumps that are very good for houses which have a gas boiler and are heated with radiators. They replace the gas boiler, they sit outside, and they put in hot water around the radiators and into a hot water tank. For flats, they are generally not a good solution. First of all, they're nearly all too big for flats. The heating power is too large. And probably a better solution for flats is air-to-air heat pumps, which are also called air conditioning. So that you have the unit looks very the same. It sits outside. The whole back row of, if you go out of Duke Street onto the little side alley here, it's all filled with all the units from all the shops. They're all heated by air-to-air heat pumps. And in flats, the heating units indoors can go above doors and places like this where you're not using the space. So, but getting planning permission for doing it, I can't help. This is where what I have been urging the council to do, I've been haranguing them, and I've been working on the project myself, is to have examples of people who have solved problems so that other people can look at them and say, yes, I just do it like they did it. And that is, whereas at the minute I just meet people, every person is solving a difficult problem by themselves. Installers are trying to solve difficult problems by themselves. So I don't know how to answer your specific... Everybody is reinventing the wheel.
Is there any national organisation which is now beginning to look at these problems? Because clearly, as you say,
I think the big move has not been the big effort has been for houses. So the heat pump installation effort, the £7,500 heat pump grant, that's pretty effective, and the things are moving for houses. But I haven't seen anything for flats, I'm afraid.
Can I say something specific on that? I think there is talk about communal heating.
Yes.
For hard to heat.
Yeah, so, but the problem with that in this country is that somehow it's a path we haven't taken. We need to sort of wind back and sort of go back down that path. And it's sort of beyond my scope to really advise about that.
Thanks so much for a very provocative talk. There's much I would dissent from what you've said, but taking things forward in a more positive spirit, you haven't spoken much about funding, and if there's to be any realistic hope of persuading local authorities, groups such as the Richmond Society, and of course building owners, it's to look into the ways of enhancing funding for maybe a series of modest measures rather than radical measures. That is absolutely critical, and if you've been involved, many folk here are, we're looking at putting in, replacing glazing, adding secondary glazing, dealing with putting in solar collectors, etc. That costs money, not least if you take your gas boiler out and replace it with a heat pump and then have to change all your radiators and pump and pipe work. That is absolutely fundamental, and until such time as government, central government, gets its act together and addresses this to enable local authorities to facilitate.
So are you thinking now about houses, domestic dwellings?
All residential and indeed other buildings as well. But you're taking quite a strong radical view, and in fact I would criticise your view, absolutist view. It needs to take into account, they call it the aesthetics, the character, the quality of places and buildings. But the key point is that of funding, and until that is solved, and there's a real incentive to carry out a series of measures or major measures to a property, whatever its use, if it's a flat or a private house, then little progress will be made. That is the heart of the question. Where does that funding come from? Maybe in long term, reduced prices, reduced costs of running, operational, but that's a long-term aim. It's to get it fundamentally for the capital expenditure. And just one other point, there's plenty of organisations that are advancing clear, sound guidance about how to reconcile measures for enhancing performance of buildings with their look. And Historic England is one, which is producing a vast amount of good documentation about how to square the circle, so you don't bugger up the facades of buildings and mess up their windows and their roofs with solar collectors and all the rest of it. You can carry out measures and still keep their qualities. I commend, look on the websites, Historic England produced a vast amount of useful guidance on that.
Okay, so there are several points that you made there. So the first is to say that you think I'm being absolutist. I've just told you the situation in which we find ourselves. My thing to you is, what are you going to do about it? And what is the Richmond Society going to do about it? Okay. Can I say, I'm just a person. When I'm saying everybody is going to do this, it's just going to happen. It's historical inevitability. If you disagree with me, great. We'll just see what happens. Regarding funding, I have heard a lot of sort of whispers from the council about loans being available, cheap loans being available to fund retrofit measures. So I know it's happened in other councils in other parts of the United Kingdom, so hopefully it will happen here soon.
Can we go on to the lady there? Ian, further over.
Hello. I really admire what you've done to your house, and I've been trying to do the same thing to my house for quite a few years, and I haven't been very successful with finding suppliers. And I've got quite a lot of questions. So one, I haven't been able to find suppliers, and two is, the way to go about it. I think first you have to insulate the house, and then you address how you're going to heat the house. So first you have to put a coat on, and then you think about heating the house. Yeah. And I have never been in a house that has a heat pump, but I have heard that when you have a heat pump, you can't heat your house to the same degree as you can with a gas boiler. And I need it increasingly warm. So as somebody who has a heat pump, can you say that you can heat your house as much as you could before with your gas boiler?
Yes, the house is warmer. So the house is 20... It's about 20.0 degrees. It varies by about a tenth.
20.0 degrees.
24/7.
24/7.
It could be warmer. I keep it the same temperature each year because I take a lot of data on the house and I don't want to change something. I want to see how it varies from year to year.
Yeah, but I think 20 degrees is not very much.
So if you want it, but it could certainly be warmer. Every degree warmer you make it, it costs about 11% more. But that's fine.
If you like to have it 25, you can have it 25.
Heat pumps will heat your house warmer, absolutely no problem. What I would recommend is there is a website called visitorheatpump.com. And if you go on there, type in your postcode, you will find houses in the vicinity who have had a heat pump, who've signed up, and you can go and visit them and see what they're like, chat to the people. My address is in there, so if you see that, you book on that and come along. So you asked about the insulation. You put your coat on first before you. Yes. So I think, in retrospect, the thing I would not have done into my house of all those things I had done was the insulation. It was very expensive, and it was a lot of work, and it was very disruptive. And I understand now that I could have just had a bigger heat pump.
Even with your solid walls, because I've got solid walls as well, and they're very cold.
Any home that can be heated by a boiler can be heated by a heat pump. That's just a fact.
So out of all the fittings that you've done, which one do you recommend people to do first as the most important, if you could say that?
I can't give you a golden rule because it depends on the person. What I'd say to what I said to this gentleman over here, first of all, catch your breath. Take your time. Some people feel very bad about carbon emissions, and they feel, I've got to do something, I want to do something, and I'm really desperate to do something. Just think about the things you want to do.
I've thought about that a lot.
So what I'd say is drop me a line, go to protonsforbreakfast.com, and you can send me a message, or visit a heat pump, and talk it through with somebody, what to do. But your perspective is different from another person's perspective. So things that you can do is find out what temperature it is that you want. So many people like 23 degrees, that's a really toasty house. So if that's the temperature you want, spend some money on a thermometer and just, is that the temperature? This is what I want. So.
And is it really true that you have to replace all the pipes? Because that means you have to go into the water.
No, it's not true. Speaking with installers, I have not come across a house where all the pipes had to be replaced. There have been houses where the radiators have had to be replaced, but not most of the pipes. In general, they won't need to be replaced.
Okay, thank you.
Can we pass it to the gentleman next to you? So. It's been answered, okay. So.
This lady here.
Two important points.
Hang on a second, wait for the microphone. Wait for the microphone.
One point which you didn't really very mention, but insulating our homes is one of the most important things. As you mentioned, after the war, there were the cavity buildings and houses.
Yes.
Pre-war houses were only a single brick. Initially, they were just the cavity, then the cavity increased from 50 to 100, and then the cavity walls started being filled in. These are very important points. Insulating, whether externally, whether internally, insulating pipes, insulating boilers, insulating walls, filling in cavity walls is extremely important, and maybe even cheaper than installing pumps.
It's very cost effective, very cost effective.
It's very cost effective. The other point I'd like to make is you mentioned, and you are absolutely right, that planning committees have no professionals. In my architectural career for over half a century, I have been fighting with planning committees where there are a lot of, they just reject to have specialists, technical people, architects on committees.
Can we turn this into a question, please?
And the question is, also the government now is trying to transform a lot of the rules of building regulations and planning regulations in order to sort out a lot of problems with the housing in this country. But my question is, how do you really reform the planning committees, like in this society and in Richmond Council and all over this country, to accept architects and technical people to give advice inside the planning committees?
I don't know. I absolutely don't know. It's frustrating, but it's how it is.
It is crucial. It is crucial.
One of the current problems with persuading people to move from gas to electricity and heat pumps is that gas heating is so much cheaper per kilowatt hour than electricity. How do you see this moving? Is gas going to become much more expensive? Are they going to cut the price of electricity?
Well, it's not cheaper than my house, but for sure. So
No, I mean the cost per kilowatt hour.
The cost per kilowatt hour is cheaper for me. My heating is incredibly cheap. So I buy electricity at night for 7 pence a kilowatt hour.
But if you had a gas boiler, it'd be even cheaper. Because per
No,
kilowatt hour,
no. If you have a gas boiler, it's about 6.5 pence per kilowatt hour. Wait to the end of the answer. Right. I buy electricity at 7 pence a kilowatt hour, and then I use it to run the heat pump. And for every kilowatt hour of electricity, I get 4 kilowatt hours of heating. Right. So my heating costs about 2p a kilowatt hour. Right. Right. And I'm very happy with that. Right. Now,
so how do you get such a cheap tariff for electricity?
Octopus. so what I have is a battery. Now, batteries, again, are very expensive, but batteries are getting cheaper, and they are only going to get cheaper and cheaper. And eventually, when I bought the first one, it was £10,000. In 10 or 15 years, as I get another one, it'll be, well, now the replacement will be £8,000. At some point, these things are just going to become ubiquitous. And then the cost, it's a different sort of structure. That's in a way a little detail. But yes, I agree absolutely. The running cost is absolutely critical. And I think the governments are working to try to rebalance some of the costs between electricity and gas. And the cost of electricity, the way the so-called market that establishes the price is very, very, could be reformed. But
let's have Bill, please.
Thank you for an absolutely excellent talk, particularly when we've got an American president who's a climate change denier taking office in 2 weeks' time.
I thought it was just me that noticed that, but you noticed as well, did you?
What I wanted to ask is, we're a big society, not many people here because of the bad weather. Could the society send out on one of your emails a summary of your recommendations?
Sure. I would be happy to write you a paragraph.
I mean, there'll certainly be a report of this forthcoming, but I mean, one of the problems has got to be obviously that everybody's property is individual, it's all different.
Exactly so.
So the solutions are going to be different for everybody. But, you know, what I would say is that every journey, the Chinese saying, every journey begins with the first step. And yeah, that's what I think we need to be conscious of, and so well articulated by Michael, is that, you know, we need to take those first steps in order to stop the ultimate conclusion. I'll take the two more questions. So Ian first.
Yeah, so I just want to echo first of all the gentleman here. Thank you very much for a very good overview there. I think the one question that I have, I've been looking at this for some time as well, like some of the other people, and you know, I've always been told in Richmond you can't install solar cells because it will just be turned down by the council. So has the position of the council changed there now? Is there anybody who actually knows this?
What sort of house are you living? Is it listed or
is it Victorian house? Yeah, it's
the last time
similar to one of the ones you showed on the pictures. It's on the hill, and the front of the house is actually south-facing. So if I effectively installed solar panels, it would have to be on the front. So then overlooked by the road, and you know the people on the road have always said no. So what do we do?
The answer is I'm not sure, because you may well have, I can't remember what the permission, you may have just by default installing a certain amount of solar panels, you may just have the right to do that. You can inquire of the council. I don't know who the person to ask is, but the two things I would say is that obviously if you've got some south-facing roof, it's just the solar panels will soak up. If you install a standard installation of solar panels on a south-facing roof, that's called a 4 kilowatt peak installation, and you can do that without asking anyone's permission, aside from planning permission, but you don't need to ask the electricity company's permission. In 1 year, it will generate about 4,000 kilowatt hours. If it's on the west or the east, it will generate about 3,000 kilowatt hours. If it's on the north, it will generate about 2,000 kilowatt hours. So if you've got a roof facing in any direction, think about putting solar panels on it, because the solar panels are cheap. They are cheaper than slate. That's the situation we're in now.
Yes, I started 10 years ago doing all this.
Yes.
So I just reassure people, financial matters, the cladding cost 9.3, but I got a grant from the government of 7.8. And the heat pump I did last year, the same as yours, the grant is 7.5, I think it is.
£7,500, yes.
And I had 5 installers come round to tell me all about it. And the lowest was 9.3, 10,000, 2 at 12 and 1 at 15. So I took one of the 10. So again, the differences are not too financially terrible. The hot water system and the radiators all work fine on the front garden heat pump. It's a fairly sizable thing. It's almost the height of the grand piano over there.
Oh, wow.
It's a 7.5 kilowatt one.
Yeah.
The energy performance certificate people who have to come round and inspect in any case claim that I only need 4.7. And that's because it's got the triple glazing, it's got the external cladding, and the remaining problem is cold coming up from the foundations, because all the outside walls at the bottom are cold. So I'm now lining them with thick chipboard, but I can't think of any way of that's the last little bit.
Yes, the one, I was just saying to Stephen earlier on, the one step I didn't take in my house was to insulate the floor. So you can lift up the floorboards, put insulation on and seal the air gaps. I thought a lot about it, but I decided I would prefer to remain a married person and didn't do that.
But how would you deal with cold coming up the walls?
Well, cold will come up the wall a little bit. Is it cold or is it damp?
There's no damp problem.
Well, I mean, cold will come up walls, but if you've got external wall insulation, doesn't that reduce it?
Yeah, but it comes from the foundations, the cold, doesn't it?
Okay, well,
It's a terrible break between the soil the house is built on.
so I insulated all the way down to the ground, and I have not found heat leaking up from there to be an issue.
I'm just going to add another bit into that. If you insulate the typical Edwardian house between the floors, you're actually stopping the airflow, which is crucial to keeping it dry.
Well, you wouldn't insulate between the floors. You'd insulate just the ground floor.
But I mean, likewise, there's a reliance. I mean, the air bricks on the front of the house require, the airflow through the house under the floor.
So we're getting technical now, but I promise you there are ways to deal with all that to make a very comfortable home. My cellars, bloody hell, I don't have a cellar. So the answer is I don't know. Well done, you have defeated me. I will now retire in shame and go home.
Somewhere to keep you warm.
There is absolutely no need for Michael for you to retire in shame. I think you've done a sterling job today. So thank you very much for your education to us and for the challenge, which I think we will have to rise to, and every person will need to rise to it to, as I said earlier, to sort of prevent the catastrophe that otherwise is upon us. So thank you, Michael. I've got here a little something to say thank you very much.
Oh. Thank you very much.
And included in there, we didn't discuss this, but there is, of course, the importance of trees. So
wow.
the Society has produced a book here, £10, available here, and it's The Walks Around Richmond. Now, our next event is... I may need Lizzie to help.
We're waiting for more information.
What's the date?
We're hoping it'll be the 13th of February.
13th of February. So we're not sure yet what it will be about, but stay tuned and we'll be in touch. So thank you very much, everybody, for coming, and I hope you've enjoyed it as much as I have.